Hey, what's going on guys? Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms. And let's continue with our graph implementation topic. And before we proceed further, I request you guys to please watch the previous videos in this DSA playlist in case if you missed, because this graph implementation is an ongoing topic and it is divided into multiple parts. You will not fully understand this video if you have not seen the previous few videos. That is the first and second graph implementation video. Please watch them all in one single go if possible, but at least watch them one by one in the proper playlist order. Okay, so I've dropped the playlist in the video description. For those who have already seen the previous videos, you already know what is graph data structure. You already know how we are going to implement the graph data structure, what is going to be our approach, what are the different functions that we are going to implement. You've also started coding in the last few videos. And we also did the add vertex operation, right? So this is something that we've covered previously. So in today's video, we're going to do a very important operation, which is addition of edge between two vertices. So this is going to be the add edge operation. Okay. And when I say implement, it means that we are going to write C++ code. So we'll first understand the entire working, entire logic. We'll take the example. We'll go line by line in the algorithm so that we understand it properly. And then we will jump to the C++ ID and write the code. Okay, so make sure you watch this video till the end. Let's start off with add edge operation. Now we are assuming that we have already added multiple vertices. In the previous video we did the add vertex operation, right? So let's assume over here, you can see on the right hand side we have 3 vertices. Let's add the ID. So these are states, right? Each vertex is a state in our use case. So let's say we have state ID 1, which is for Maharashtra. So let's write MH over here. This is 2 for Goa and this is 3 for Madhya Pradesh MP. Okay. So these are the 3 states, 3 vertices. Let's assume that we've already added them. That is because we've done this previously, as I mentioned. And now they are in the graph. So in the code, in the memory over here, this is something how it would look like. Graph G is nothing but our graph object, correct? And inside this graph G object, we have a vector named vertices, correct? This is the graph class. All this we've covered previously. I'm just quickly going through them for revision purpose. So vertices is nothing but a vector. A vector is a dynamic array which comes from the STL library. So at index position 0 of this vertices vector, we will have our very first vertex 1. The name is MH. MH stands for Maharashtra in this case. It will also have its own edge list, which is in this green box, which is blank right now. That is because we don't have any edge between any of the vertices, hence it's going to be blank. So let me fill out the other details. So in the memory, in the coding side, actually what is happening behind the scenes is this scenario. This is how it looks like, and this is just for visual representation. So right now we do not have any edge between any of the vertices. So we need to connect Maharashtra to Goa, we need to connect Maharashtra to Madhya Pradesh, we can connect Goa to Madhya Pradesh, so on and so forth, right? So these are the edges which need to be added. So for that we will have to write some code, we will need some algorithm, we will need some logic, right? So how do you do that? So now that you've got an overview and proper revision and the background, let's see how we will add a particular edge in the coding side, in the implementation side. So this is the main function. So main is nothing but the main part where your C++ program starts to execute. We are implementing this in C++, right? So in the main function, basically in the menu driven program, what we will say, we will ask the user to enter the ID of the source vertex. So user will enter ID 1. Let's assume user enters 1. Okay. 1 is nothing but the ID of Maharashtra. Then we will ask the user to enter the ID of the destination vertex. Let's say the user enters 2. So we need to add an edge between Maharashtra and Goa. Okay. Alright. We also need to get the weight of the edge. I hope you know what is a weight. Weight in this case is the distance between Maharashtra and Goa, right? Let's say user enters 500. Alright. 500 is nothing but kilometers. Let's just assume. Okay. And lastly, this is the command where the user will actually call G dot add edge by ID. So G is nothing but the graph object G, correct? Inside the graph class, we will have a function, our own user defined function, which will say add edge by ID. This is our own name. We will pass these values that we take from the user. What are these values? ID is 1 for the source vertex, id2 is 2 for the destination vertex and the weight is nothing but 500. Alright. So these are the three things that we will pass in this add edge by id. Now this add edge by id is our own user defined function as I mentioned. So let's see what this function is, because this is where the actual coding will happen. Correct? Okay. So on the left hand side, you can see our graph add edge operation. So this is the entire pseudocode. So this whole thing is basically the pseudocode, which is nothing but part English, part code for the add edge by id function. Alright. Now don't get intimidated or don't think that this is difficult. It is a little lengthy compared to the add vertex operation, but we will go step by step. We will dry run this code right now, and that will give you the best understanding of what is actually happening, right? So in the main function, what we did, we passed 1, 2 and 500 and we called this add edge by id. So this function is called with the arguments or parameters passed as 1, 2 and 500. Correct? Alright. So now let's go step by step, dry run this entire function, and then we will also make all the changes reflect over here in this diagram so that you understand what is exactly happening in the add edge operation behind the scenes in the memory also for the best understanding. Alright. Okay. So first step, we say check is equal to check if vertex exists by id and we pass id1. id1 is nothing but 1. Now what is this check if vertex exists by id? Again, a huge ass name, I know, but I name the functions in a way that they are understandable by the name itself. And if you just read it one word at a time, it is check if vertex exists by id. What would this function do? It would check if a vertex exists by its id, and you simply have to pass the id. So what is this? This is again a user defined function which we will have to write to check if vertex exists. Now, if you watch the previous video, we have covered this function, that is check if vertex exists. I'll show it to you on the screen. But basically what it does is it will go through all the elements in the vertices vector one at a time. It will start from 0. It will check this one with what you pass over here. And if there is a match, it will return true. And if it completely exhausts this entire list and it doesn't get a match, it will return false. That is what check if vertex exists does. Okay. So I'm not gonna reiterate all the steps inside. Let's assume that you've already seen it. If not, please watch the previous video. So, okay. Since we are passing 1 over here and we know that there exists a vertex with the id 1, this will return true. So, true will be stored in check 1. Similarly, check 2 will happen. We will pass id 2. So, basically, before adding a edge between two vertices, obviously we need to check whether those vertices already exist or not, right? You can't simply randomly pass any id over here. Let's say you pass 16 and 11 and these IDs don't even exist in the graph, right? If they don't exist, then obviously you can't add an edge between them. So that's why we need to make that check initially. We are making our code as valid as possible. We could have, not written this code and we could have entered the actual values only. But I'm adding these extra codes so that you don't make any mistakes and your code becomes more valid. So basically extra validations over there. So first check 1 and check 2, both of them will return true because id2 is going to be 2. 2 also exists. You can see GA, that is Goa, has a state ID of 2. Now the next thing, the third step is we check. If check 1 and check 2 equals to true, then what it would mean is that there exist two vertices with IDs 1 and 2, correct? And only then you can proceed with the addition of edge between the two. But now we will also have to do one more check, that is a third check, that we have to check whether there exists an edge already between the two or not, correct? We just checked that two vertices exist with these IDs, but we still have not checked whether there exists an edge between them or not. So we can't add an edge where the edge already exists, right? We are assuming that in our program we can add only one edge between two vertices, and that edge also has to be undirected. Undirected means if you add an edge between Maharashtra and Goa, it would also mean that there is an edge between Goa and Maharashtra. So it works both ways, and that is what an undirected graph is, right? So the third check will be inside the first if. So this first if is going to be starting from over here till the very end, and then there would be an else part, right? If the check 1 and check 2, if any one of those checks become false, there would be a else part below which I have not written, and in the else part we can simply say that there exists no vertex with a particular ID, right? So that part I have not written over here. We'll write it in the coding part. What we are more interested is when both these checks are true and when the third check is false. Okay, because let's see what this third check is. So this check 3 is, we are saying check if edge exists by ID. Now again, this is one more user defined function which basically takes the ID and checks if there exists a particular edge between these two vertices. Alright, so we have not seen this user defined function. So what we'll do is we will pause this function operation over here, that is the add edge by ID will be paused at this step, and now we will call check if edge exists by ID first. Let's see how and what we have inside this function. Okay, and then once this executes, we'll come back and start the execution or resume the execution from over here. Okay, so when you call this check if exists by ID function, this is that function, and let's see what this function does. So over here you pass ID1 and ID2. ID1 is 1, ID2 is 2. This is what we've passed, right? So we say vertex v and we call get vertex by ID and we pass 1. Alright, so there is one more user defined function over here, get vertex by ID. So just by looking at the name, you can understand that it will return a vertex object which has the ID 1, and that will be stored in this v object, correct? But of course we'll have to see what exactly happens inside this function. So let's see this function now. So when you call get vertex by ID, the function call transfer will go to this function over here, which is get vertex by ID VID. VID is nothing but the ID that we are passing. We are passing 1. Now we say vertex temp. We call a loop from I equals to 0 to vertices.size. Vertices is nothing but the vector inside the graph object G. The reason why we can directly say vertices.size is because this get vertex by ID, check if edge exists by ID, add edge, all these functions are inside the graph class itself. So when you create an object of graph class, when you say graph G, G will have all these functions, which means that inside these functions you can use this vertices data member directly, right? So we are saying from 0 to vertices.size. What is the size currently? Vertices vector has 1, 2 and 3 vertexes, which means that the size is 3. So we will go from 0 to 3. Inside that we will say temp is equal to vertices.i. So initially when I is 0, vertices.at I means vertices.at of 0. What is there at vertices of 0? You can see we have the first object, which is the first vertex or first state. So that will be stored in temp. Now we will check if temp.getStateID equals to VID. Temp is currently having the values of the vertex at 0 index, correct? Which means temp is having a ID of 1 and temp is also having a name of MH and all the edges which are blank right now. So when you say temp.getStateID, temp is currently having ID as 1, right? Equal to VID. What is VID? We say VID we passed 1, correct? Because when we say get vertex by ID, we passed ID 1. ID 1 is nothing but 1. So is 1 equal to 1? Yes. So now we say return temp. So temp will be returned from get vertex ID back over here. And what is temp? Temp is nothing but a object of type vertex. So that will be catched by this vertex V on the left hand side. So we will have nothing but temp, correct? So V equals to temp, which means V now has the value of 1 MH and the blank edge list, correct? Alright. Now since this function is done, we will continue with this function check if edge exists by ID. Remember, we have to check whether there exists an edge between MH and GA. That is what this function is doing. So the very first thing that we did is we created a temporary vertex V and we got the values of the vertex with ID 1 from the vertices vector of the graph object and we stored it in this vertex V. Why we did that? Now we want to check its edge list, correct? What we want to do, we want to essentially check whether there is any value in the edge list of MH or GA. So how do you do that? So the next step is over here we create a list object E of type edge. So remember, the edge class has two data members. it has weight, and it has destination vertex. I'll put it on the screen over here. So what we did is we created a list named E, and it has a type of edge. So list is nothing but a STL again, which is provided in the STL library itself, and the type of list we are creating is this edge class, which we have pre-created already. So basically it will store list of type edge. Okay, and this is what is happening at this third line. We say E is equal to v dot get edge list. Now every vertex will have its own edge list. Now if you happen to see this structure, this is one vertex, correct? Inside this vertex, what do we have? We have its state ID, we have its state name, and this green box which is empty right now is nothing but its edge list, correct? It's of type edge, and it's also a list. So each of the vertex has its own edge list, which means that each of this vertex stores a list of edges that it is connected to. So that is what this function will return. Okay, and you'll see this in the coding part. It is just returning the entire list as it is. I'll explain to you in the coding part if you are getting confused, but what this will do is it will return a list which will be stored in this list E, which we temporarily create, and now we simply have to loop through this list. We say auto it equals to e dot start to e dot end. I'll explain what this auto is in a second. Basically you are going from start to end of this list, and we check if it of get destination vertex equals to id2. So let's say this is E. E is nothing but a list. So let me write list over here. List E, which will store objects of edge type, correct? So each object, that is this inner rectangle, is nothing but a edge object. What does a edge store? A edge stores destination ID and weight. So let's say this is over here 1 and 500, or let me write 2 and 500. This is 3 and 1000 or 100, and so on and so forth. So this is nothing but edge object. A collection of these blue boxes is nothing but a collection of 3 edges which are stored in this list of edges which is named as E. Okay, so hence E is nothing but a list which stores object of edge type, and that is what this is looking like. Now when you are looping through this list E, you say auto it, and auto is nothing but a keyword in C++ which basically makes this variable take the same data type that it is pointing. But basically what you are doing is you are creating a variable called it, and it will initially point the very first object in this list E. And when you say it of get destination vertex, so if this is the first object, when you say get destination vertex, that is this function, this will return the ID, that is 2. Okay, so 2 will be returned over here. We will check whether it is matching with id2. id2 is nothing but 2. So if this is equal, what it would mean that we are returning true. So we say then return true, and this check if edge exists by id will return true, which means that there exists a edge between id1 and id2. Now right now over here all these edges or all these edge lists are blank, which means we don't have anything inside the list E, right? Inside this E, when you say v dot get edge list, v is nothing but temp is nothing but the very first vertex object which was returned from get vertex by id, right? So it returned a vertex with id1, name mh, and a blank edge list. So when you say E equals to v dot get edge list, this blank edge list is stored in this E. So when you are looping through it, it will not loop because there is no value only. It will end the loop and we will ultimately return false, which would mean that when you want to check if edge exists between id1 and id2, we are returning false because there is no edge between the two. Okay, so I hope you understood how check if edge exists by id is working. Now if you are still having a little bit of confusion, I would recommend that you pause this video and dry run this pseudocode again. But right now what is happening is this check if edge exists, where you passed 1 and 2, will return false. So who had called check if edge exists function? Remember over here, let me just bring it back. This add edge operation had called check if edge exists over here. We had passed 1 and 2 and now it is returning false. So it will come back and false will be stored in check 3. So now we will use a if block. We will say if check 3 equals to true, then we will say edge already exists, but since it has returned false, now in the else part is where you actually add the edge. So check 1 and 2 we determined that we have vertices with ID 1 and 2. Check 3 we determined that there is no edge between 1 and 2, and in the else part now is where you actually add the edge. So this loop or this part is where you will actually add the edge between 1 and 2, that is vertex 1 and vertex 2. Okay, so how do you do the addition? Now remember that our graph implementation is an undirected graph. So when I add an edge between Maharashtra and Goa, it also means that I will have to add an edge between Goa and Maharashtra, right? So programmatically speaking, we will have to add 2 edges or 2 entries in the graph object. So one entry will be for Maharashtra object and one entry will be for the Goa object, correct? So this is why we have 2 blocks over here. We have the if block and we have the else if block. So let's see what these 2 blocks do. So over here we check if vertices at I. So we will first say the loop is going from 0 to vertices.size. So 0 to vertices is nothing but our vector which has 3 elements. So we will go from 0 to 3. Now we say if vertices at, so initially it would be at 0 dot get state ID. So what is the state ID at 0? It is 1. So we'll say if this is equal to from vertex. So from vertex is nothing but the first ID 1. Okay. So let me just rename this from vertex, or you can just assume that this is ID 1. Okay. From vertex, or you can also say it is the source, but over here it is the ID 1 and ID 1 is nothing but 1. So is 1 equal to 1? Yes. So this means we have to add an edge between Maharashtra to Goa and that has to be updated in the Maharashtra object. So how do we do that? So we'll say edge E, you'll create an edge object. Remember what is the edge class? It has destination ID and it has weight. So 2 vertex is nothing but ID 2. Okay. ID 2 is nothing but 2. And what is the weight? Weight is nothing but 500. So you create an edge object, you call it E, you store destination ID as 2 and the weight as 500. Remember you passed W, which is the weight as 500. So that is what you did over here. The next step is you say vertices dot at, again at is nothing but 0 initially for the first step, dot edge list. So this edge list is nothing but the list in every vertex object, right? So remember in the vertex class, we have state ID, we have state name, and we have this green box which is nothing but the edge list. In our code we have named it as edge list itself, E small and L capital. So we say edge list, which is a type of list. What is list? List is nothing but a STL. So it will have its inbuilt functions. One of it is pushback, push underscore back. You have to write it as it is. And what pushback does is it adds a particular element into the list. Okay. So what you are adding, you are passing this E object as it is. So this 2 and 500 is basically pushed into vertices at 0, right? Because remember we are at the first iteration, we are saying I equals to 0 for now. So vertices at 0 is this element, we are accessing its edge list and we are saying dot push and we push this E object into it. So we push the first edge. So what we did, we added an edge between Maharashtra and Goa. So let me add this over here also. But as I said, remember we also have to add an edge between Goa and Maharashtra also, which means that we need to make this same entry over here also. But over here we will have to add destination ID as 1 and the weight will be 500 only, correct? So how do you do that? So that happens in the else if part. So when the if block is executed, the else if will not be executed for the first time. You will come at the start of the for loop and now I will become 1. So let's say I has become 1. So now again we will go inside this loop. We will check if vertices at I has become 1. So vertices at 1 is nothing but Goa. with the ID of 2. So we are saying vertices at ID 2, we'll say get state ID which will return us 2. Is it equal to from vertex? From vertex, as I mentioned, remember, is ID 1. Okay, in the coding it would be ID 1. What is ID 1 that we have passed initially at the top? It is 1. Is 2 equal to 1? No. So now if will not be executed. Now we'll go to else if. In the else if, we will check if vertices at get state ID, which is again vertices at 1 and get state IDs will return us 2 over here. Is it equal to 2 vertex? What is 2 vertex now? 2 vertex is nothing but ID 2, which we have passed initially as 2. So 2 is equal to 2. So in this case again we will create a edge E, and we will now pass from vertex. From vertex, as I said, is ID 1. So we are creating 1 comma weight is the same 500. So we create a new edge E over here with destination ID as 1 and weight as 500, and now we push this into the vertex where we are. So vertices at I is nothing but 1 right now. So vertices of I is over here. Dot edge list means we are accessing the edge list, and dot pushback means we are pushing this edge E into this edge list, which means we are pushing it over here also. And now guys, if you can see, we have connected Maharashtra to Goa and updated the edge list of Maharashtra with a edge, and the destination ID is 2, which is ID of Goa, correct? So this edge is done. Similarly, in the object of Goa, we have added a edge in its edge list with the ID 1, and 1 is the destination ID of Maharashtra. So for Goa, this ID is the destination ID, which will basically mean that even this is connected. So now we have created an undirected connection between Maharashtra and Goa. Maharashtra has the ID 2 because for Maharashtra the destination is Goa. For Goa the destination is Maharashtra. So vice versa IDs are also swapped in the edge list. And now the loop will ultimately come to an end, and at the end you can say print edge added successfully. So this, my friends, you can see is the add edge operation, which will add 2 edges for every add edge operation. Okay. The reason why we have to add 2 edges is because, as I mentioned, it is an undirected graph and each vertex has its own edge list. So if you add an edge between Maharashtra and Goa, both of their edge lists have to be updated with a particular edge object inside the edge list, correct? So this is the entire pseudocode for add edge operation. Now I know things must have been heavy so far if you followed the entire video. It's a little lengthy video, I understand that things have become a little confusing. But what you can do is you can pause this screen and dry run this entire code again once and add an edge between Maharashtra and Madhya Pradesh, the same way we did it for Maharashtra and Goa. Take a pencil and paper and run this code one by one, line by line, and I'm pretty sure that you'll get the whole hang of it. Okay, let's now jump to the C++ IDE and see the code in working, in action. We have to write quite a lot of code, so let's jump to the C++ IDE. Okay, so as you can see on the screen, this is some code that we've already pre-written. We've created the edge class, we've created the vertex class, we created the graph class inside which we did the add vertex operation, we did the check if vertex exists operation, we also did the print graph operation, which I will explain later on. It's a printing of graph basically, but just below this check if vertex exists, let's write our add edge operation. Okay, so I'll say add edge by ID, and you can see the pseudocode on the right hand side. It's pretty lengthy. So ID 1 is nothing but from vertex, ID 2 is nothing but to vertex, in case if you are looking at the pseudocode, and W is nothing but the weight. So I have named W as full weight over here. You can also name it as W if you want, but let's keep it weight. Now inside this, we first have to do the checks, right? Check 1 and check 2. Let's do that. So we create 2 boolean variables, check 1 and check 2. We say check if vertex exists by ID. We pass from vertex and to vertex. So this is the check if vertex exists by ID function. I'm assuming you guys already know this. After this, we will say if check 1 and 2 are true, it would mean that there exist 2 vertices with their individual IDs, whatever you pass in the main function, right? So we will do one more check. We will say boolean check 3 and we will say check if edge exists by ID. Now we still have to create this function, right? So let's go up over here and we will create this check if edge exists by ID function first. So I'm just copy pasting code so that I don't waste your time. So this is the code. Of course, you'll get the entire code on our official website. You can check it in the video description. You'll get the link. This is the same code for the pseudocode that we just went through. So not going through that again. Basically, you create a vertex v. You say get vertex by ID and you pass from vertex. You get one of the vertex and store it in this vertex v. You create a list e of type edge. You get the edge list of this vertex and store it in this e variable. And now you simply have to go from e.begin to e.end. This is how you iterate in a for loop in a list variable. Okay, so list is nothing but STL, right? So when you create an object of list, the way you iterate through them is by using these inbuilt functions of that list. List is nothing but a doubly linked list. You can relate it with a doubly linked list. It operates pretty much like that. What this auto keyword does is it takes the data type of whatever there is on the left hand side. So this means that if I say auto I equals to 5.7f, it would mean that I is a float type. Okay. In case if I say auto I equals to 4, it would mean that I is an integer type. So whatever value you pass on the right hand side, the data type will be automatically selected for that variable. This is what this auto keyword does. Okay, this might be new for many if you are beginner in C++, but yeah, this is what this keyword does. So basically it will take whatever data type this list E will have. What will be the element inside this list? It will have an object of type edge. So this IT will point to the object, that is the very first edge object inside this list E. Okay, and then we will get the destination vertex ID of that object, edge object. We will check it with the to vertex because we got the from vertex and stored it in V. Now in the edge list of vertex V, we need to check if there is a to vertex ID. Correct? So if there exists, then we will say flag equals to true and return flag. You have to return flag. You can simply say return true over here. One less line of code. And over here you can say return false. You don't need this flag variable. But if this for loop completes its execution and you come outside the for loop, you will return false, which means that you did not find any variable or any edge inside this vertex which had the destination vertex ID. So this get destination vertex ID will be another function which will be there inside the edge object. You can see we created this edge class over here. Inside that we have get destination vertex ID, which will simply return the destination vertex ID variable. Edge class has two data members, destination vertex ID and weight. The reason why we don't have source vertex ID is because every vertex will have its own edge list. So every vertex has its own ID itself. So that is its source ID itself. So in the edge list, you don't need to have source because for every vertex we will have individual edge lists. Correct? Alright. Again, coming back to check if edge exists by ID, and this is called over here. After this, you'll say if, and if check equals to true, it means that there exists an edge between get vertex by ID from vertex dot get state name. It will get the state name of whatever vertex ID you pass over here. So if it is 1, then you will get vertex by ID dot get state name will get its state name, and then in brackets again you pass from vertex ID. So this is just for presentation purpose. Okay, you can simply print edge exists between the two vertex also, but this will print mh its ID, then it will say and then it will print Goa, in bracket it will print its Goa's ID, provided that you pass mh and Goa, that is you pass 1 and 2 like how we have assumed. Now in the else part is where you actually add the edge. Correct? Because if check 3 is false, it means that there exists or there doesn't exist a edge between from and to vertex. So this is where you actually add the edge. So this is the code for the addition of edges. You start from 0 till the number of vertices. For the first time you add the edge between one edge, and in the else if you add the edge between the second vertex. So this is for updating the edge list of one vertex. This is for updating the edge list of second vertex, right? So we need to add two edges, right? One for a particular vertex each. So hence we will do if and else if, and we will do the corresponding matching, and lastly we will simply come outside this for loop and we will print edge between from vertex and to vertex added successfully. From vertex is nothing but the ID that you've passed at the top when you say add edge by ID. Okay, alright. Lastly, after this if, this is the outer if, and we also have an inner if. So for the outer if we will have to add a else. Inside the else we will simply say invalid vertex ID entered, because if check 1 and 2, if any of them become false, it means that you added a invalid vertex ID which does not exist in the graph. Alright, correct? So this is the entire add edge by ID function, guys, and I know it is a little lengthy, it is also a little intimidating, but if you have watched this video in one go, I'm assuming you guys have got the entire flow of it. Please dry run it, take a pencil and paper and dry run it at least once. Add some real values, assume that you've already added some vertices with some values, and then call these functions step by step and go through them, and I'm pretty sure then you'll understand the entire behind the scenes operations. So now the last thing left is we have to go in the main function. In the case 4 is where you did the add edge operation. So this is where I'm gonna add the code. You'll take the ID of source vertex and destination vertex, both of them states from the user, ID1 and ID2. You'll take the weight from the user and you'll say g dot add edge by ID. So this g is nothing but an object of graph type. We've created graph class, we added, or we just now wrote the functions inside this graph class itself, that is the add edge by ID, right? This is a menu driven program that we've done in the previous videos, so not going to go through that again and again. We have certain options. We have done the add vertex and now we did the add edge. The update delete and update delete will do it later on. But let's save this. Let's go to execute, compile and run. Hopefully everything would work fine. Let's see if our addition of edge works. So addition of vertex is already done, right? Okay, so we are getting an error. Get vertex by ID doesn't exist. Okay, we still have to create get vertex by ID inside the graph class, correct? So let's go into the graph class. Let's see if we've made that code. No, I don't think so. So at the top, all graph operations, below this we'll create this function here also. So get vertex by ID has a return type of vertex, which means it will return an object of vertex type. It will take the ID and we will loop through the vertices vector. We will check the state ID. We will take the object at every index in the vertices vector. We will transfer it in this temporary vertex. We will get its ID and we will check its ID with the ID that we pass. If we get a match, we will return it over here. Okay. And this return is when we don't get a match. Then it will be a null object which will be returned. But this will not happen. Let's save this. Let's go to execute, compile and run. Okay, we are getting one more error. What is this error? Right, we still have to create ID2. So over here on the top, we will create one more ID variable, ID2. Save this. Hopefully everything should work now. Okay, one more error. Right, we have to also create the weight variable. Okay, it's compiling. Alright, finally, after resolving all the silly mistakes and errors, our program is working. Let's add vertices. We've done this previously, so I'll go quickly. So vertex added successfully. Let's add one more vertex. Option 1 is for add vertex. State ID 2. GA is for Goa. So again, vertex added successfully. Let's add one more. Option 1 for add vertex. ID 3. MP for Madhya Pradesh. And now let's do the print graph. Option 9. And you can see print graph operation. MH, its ID and its edge list. all of them are blank because there is no real edge between any of these vertices. Now let's do the add edge, which is option 4. It's asking us enter ID of source vertex, we will see option 1. Then it is saying enter ID of destination vertex, let's see option 2. So we want to add edge between MH and GA. Hit enter, and now let's add the weight, which is 500. Hit enter, and now you can see edge between 1 and 2 added successfully. Alright, so now let's see how the print graph operation looks like. If we have added the edges successfully, we will have 2 entries over here. So let's click option 9, and there you go guys. You can see now for MH, which is the very first vertex, in its edge list we have a first edge which is 2 and 500. What is 2? 2 is the destination ID of Goa. The weight is 500, which is in brackets. For Goa, in its edge list we have destination ID is 1, which is ID of Maharashtra, and the weight of course is gonna be same because there is only one edge. It's just that there are 2 entries. So let's add one more edge, this time between Maharashtra and Madhya Pradesh. So option number 4, hit enter. Enter source ID 1 and destination ID is 3. The weight of the edge, let's add it as 700 kilometers. And now you can see edge between 1 and 3 is successfully added. So again, let's print the graph. Option 9 is for printing the graph. And now guys, you can see for Maharashtra in the edge list we have 2 edges. The first edge is for Goa. The second edge is 3. 3 is the destination, or 3 is the ID of MP. So that goes as the destination ID in this edge, and the distance is 700 kilometers. Similarly, for Madhya Pradesh, in its edge list, we have 1, which is the destination ID, and 1 is the ID of Maharashtra. So MP is now connected to Maharashtra. The weight is 700 only, which is exactly the same. So this, my friends, is where we've completed successfully the addition of edge operation between 2 vertices. So I hope the implementation has been clear. I know this was a very lengthy video. Hope you've made it so far. If you've made it so far and if you've understood this code, please give this video a like. It takes a lot of time and effort to make these videos. Check out the link in the video description for the entire code. Dry run the code step by step. Take a pencil and paper, put all the values and run through each line of code and see what happens behind the scenes. That will give you the best understanding and will make things much more clear. Okay, so I'm gonna wrap up this video over here. Thank you so much for watching. Let me know in the comments how this video was, and I'll see you guys in the next one. Peace.